All right. So here's our tweeter face problem, right? We are going to have a startup, and we have all this information. And you guys told me yesterday what makes it tough is all the info. So here's our goal. We want to find all the values that are feasible, that work for all of these constraints. And then what we want to do is we want to figure out which of those values is going to be my maximum for productivity. And productivity here is how many program iterations, how many runs can I go through my program in a day. So I'm trying to figure out what's the most that I can do that's feasible, that works for this whole mess. So that's the goal. That's what we're trying to do. So what we're going to do is we're going to pick it apart. And if you remember back to the first 2 days of class, we talked about the problem-solving process, right? We have to understand the problem. We have to devise a plan, carry out the plan, and check it. So how we're going to do this, we're going to write a whole bunch of constraints. So we're going to take this and we're going to turn it into mathematical equations and inequalities. We're going to graph it. So we're going to get an overlap of all these shaded regions. We're going to look at those and determine which of those are going to be the best for our feasible region. We're going to get an equation. Do we find our vertices? We have to write something called the objective function. So the objective function, if you watch like a bunch of action movies and then in the military, right, they say, what's your objective? Like, what's your goal? What are we trying to do? So our objective function is the piece that we're trying to maximize. And then we're going to just plug in our vertices and see which ones give us our maximum in this case. We could be talking about a minimum down the road. All right. So we're going to define two variables. So this is always going to start the same. We're going to get two variables. So P is my number of programmers. What am I going to call the administrators? A. All right, let's not overthink it. So A is number of administrators. And with these two variables, I'm going to need to write all my inequalities. I'm going to pick it apart. So if I have 12 people total, what do P and A have to equal? 12 or less. All right? So these are called the constraints. The first one is P plus A is less than or equal to 12. I can have 12 people. I could have 10 people. I could have 2 people. I can't have 13 people. I can't fit them. So my first constraint is P plus A has to be less than or equal to 12. All right, if we look at the third bullet, it says you need at least 2 administrators and 4 programmers to have a chance of crushing Facebook. You can have a maximum of 9 programmers. So we get 2 inequalities from that. The administrators has to be greater than or equal to 2. The programmers has to be greater than or equal to 4, but less than or equal to 9. So if I took the minimum administrators and the maximum programmers, does that satisfy the number of people constraint? So far, so good. Okay, so that would be a feasible combination, but we haven't used all the information yet. All right, we also have the fourth bullet point talking about sleep. So it says that we can have a maximum number of hours worked in a day of 131 hours, and the programmers work 15 hours a day, the administrators work 8 hours a day. Can anybody think of the inequality that I'm going to write for that? Yeah.
15P plus 8A is less than or equal to 131.
Perfect. So, however many programmers I have, each of them works 15 hours. However many administrators I have, each of them works 8 hours. All that added together has to be less than or equal to 131 total hours. All right? This last piece isn't a constraint. This is our objective. So it says each day a successful iteration of program needs 4 programmers and 2 administrators to be available at some point during the day. We want to maximize the number of iterations. So this isn't a constraint, but it's what we're actually trying to do. So we need to write what's called the objective function. So that gives us our objective function. That's what we're trying to figure out. And the way that we write that, it's a function of P and A. All right, it's a function of number of programmers and administrators. And what it looks like is 4P plus 2A. I need at least 4 programmers and I need at least 2 administrators for my iteration. I need some combination of that. I'm trying to maximize the number of iterations. Okay, so we took the big word problem and we have it now into 4 inequalities and 1 objective function. Give me a thumbs up if you're still with me. You okay so far? Okay. What's the next step? We got our constraints, now we need to graph it. Alright, so here's our constraints. Oops. Oops. So here come our constraints. And I'm going to define the programmers as our x-axis and the administrators as our y-axis. We could have gone the other way. It doesn't really matter. And the blue equation, I found 2 points, and I just found the intercepts. So I said if A is 0, P has to be 12. If P is 0, A has to be 12. It's a solid line because it's or equal to. And then which direction do I shade? To the left or the right?
To the right.
Okay. To the left, right? That's a bad statement. To the left, correct? Right? If I put in 5 and 5, that's going to be less than 12 when I add them up. Okay. This is easy. A is greater than or equal to 2. Well, there's A equals 2. And am I going to shade up or down? Up. There is P bounded between 4 and 9. And am I going to shade out from those lines or in from those lines? In. And then this one I have to do a little bit of math. Again, I'm going to find the intercepts. I'm going to let P equal 0 and figure out A. I'm going to let A equal 0 and I'm going to figure out P. So the A-intercept is when P is 0. The P-intercept is when A is 0. I get 0, 16.4 for the A-intercept, and 8.70 for the P-intercept. I put those points up there. There's my line. Am I going to shade up or am I going to shade down? Down. Plug in a test point. Plug in 0, 0. No programmers, no administrators. They're definitely going to work less than 131 hours. All right. I didn't shade them all in because it's just a mess. But all of our overlap is this polygon here. That's what we call the feasible region. Any point in there should work for all my constraints. So if I pick a point at random, say 5, 5. 5 is greater than 2. 5 is between 4 and 9. 5 times 15 plus 40 is less than 131. It works for everything. What we're really interested in, though, is these corners. Because it's not that great to be here when I could be more and more. Because remember, my objective function deals with how many of these I can get. So if I could go here and I can move up and get more administrators, or move over and get more programmers, that's better. So it turns out what we're really interested in are these vertices. Okay? These are going to give me the most bang for my buck. They're the most, they're still feasible, but it's the most of each of them. Alright, well now I have to do some algebra. I have to solve those points. I have to figure out what they are. So at 1, P is set to 4, and it crosses the blue line. So what does A have to be? All right, yeah. Here's P equals 4. Crosses the blue line. So what is A? 8. Alright. At 3, A is 2. And it crosses the purple line. So if A is 2, this is 16. I subtract it from both sides. I divide by 15. And I get P equals 7.6 repeating. The last one is the trickiest one. 0.2. Because which two lines intersect to give me 0.2? The blue and the purple. Well, it's just a system of equations. I have an equation, I have an equation. I want to solve it just like you did on the warm-up. So if you want to use elimination, you want to use substitution, whatever you want to do, you find that vertex. I think I used elimination. So I multiplied by 15 and subtracted. And got 7A is 49, A is 7, P is 5. Now, I skipped over something pretty quickly here. When I solved 3, I got 7 2/3 programmers. What did I do to that number? I rounded down. Why can't I have 7 2/3 programmers? It would be really, it would be ugly, right? We can't have 2/3 of a person. Why can't I round it up? 7 2/3 goes up to 8. What's that? It would be what? Oh, yes. I thought you said straight desk work. All right. It would violate the constraint. If I come out of here, I'm out of the feasible region. It doesn't work. So I can go back in the feasible region, but I can't go out. So those are my combinations. 4 and 8, 2 and 7, 7 and 5. One of those is going to give the best number of iterations. So I take those values and I plug them into our function. I plug in 4 and 8, I plug in 2 and 7, I plug in 7 and 5. I get 32 iterations with 4 and 8. I get 22 iterations with 2 and 7, so this one's better so far. And then the last one, I get 38 iterations. So which is the best? If I'm hiring people, how many programmers do I want to hire? 7. How many administrators do I need? I need 5. That is my solution. So it's maximized by hiring 7 programmers and 5 administrators.